All right. So, as I mentioned, my name is Phil Zito. I'm the founder and CEO of Building Automation Monthly. We help companies train their building automation professionals to execute building automation work. So, a little bit of background on me and why you should pay attention is that started as tech, ran ops management, ran some sales, then worked as the integration program manager for a large OEM where I built backnet stacks, helped work on IP controls solutions and architectures, and had a lot to do with networking. I've got a educational, a certification, and just a field experience background with networking, IP, and all those kind of things. So in this webinar, here's how this is going to work. We're going to go through what IP controls are. We are immediately going to transition to how to digest catalog sheets and understand what capabilities an IP controller has. Then we're going to look at some requirements, talk through the design process. We're going to create a design, and then we are going to talk about just deployment strategies on mainly new construction projects, because on retrofit, IP controls aren't as bad as deploying them on new construction. So if that sounds good, awesome. If it doesn't sound good, well, I guess too bad, because that's what we're doing. So go into the questions box if you have a question, and let's dive in. All right, so what are IP controls? So here are two IP controls lines from two different manufacturers, Johnson Controls and Honeywell. And you can see the Johnson Controls IP controller right here. It has two Ethernet ports, right? Two RJ45 ports for Ethernet to connect into. And these IP controllers are just going to connect to an Ethernet run, and then, as we'll see when we start talking about architectures, they could continue that run to other controllers. We can see that this right here, this controller actually has a 4-port switch built into it. We'll talk about why this controller might have a 4-port switch built into it, how that actually affects our architecture, as well as our conversations with IT. So why IP controls? I mean, why do we need to move from BACnet, MSTP, which, I mean, let's be real here, folks. If we're talking about IP controls, we're primarily talking about BACnet IP and BACnet MSTP. I mean, you've got LAN FT10, you've got LAN EI852, and I mean, we're not even going to get into Modbus because that's not really a controller. That's more of a secondary controller. So when we're talking about IP controls, we're really talking about why BACnet IP over BACnet MSTP. The primary reason you will hear about utilizing IP controls, okay, is going to be this guy right here, speed. Okay, see, what we have to realize is that we have modem speed. So we've got MSTP, right? And that's like your old 56K dial-up modem speed. Then you have IP, and IP, depending on the controller, is really fast. But why do we need that speed? What does that speed allow us to do? So that speed allows us to do kind of three things. One is it's going to affect our install, okay? So how many of you, and I realize you can't answer me, so you're just gonna have to pretend that we're having a conversation here. All right, so how many of you have went to install MSTP controllers and do a mass download of programs and sat there for 30 minutes? And hopefully they all went through, and hopefully nothing got corrupted. The beauty with IP is that you do a mass program download, and depending on the manufacturer and how they have it developed, you're going to go and have that done in a matter of seconds to minutes. It's much faster. The additional thing about IP from an install perspective. Now, remember, I don't have a dog in this fight. I don't sell IP controllers. I don't really care what product you use. I'm just telling you pros and cons. So install speed, and also install setup and architecture. Now, I know this is for a lot of folks, they're going to say, but MSTP is so easy. We set MAC addresses and we set the baud rate and we make sure the wiring's right and it's good to go. But here's the thing. There's a lot of things that can go wrong with MSTP when you really think about it. Polarity cross, improperly grounded wires, duplicate MAC addresses, duplicate device instances, mismatch on baud rate, all sorts of stuff. With IP, it's much more organized and structured. And so IP, you simply need an IP address and whatever identifier the manufacturer is using for the controller so you can discover it to assign that IP address. And so from an install perspective, it's much easier. I know a lot of folks really get heartburn about that because we as an industry, we don't have a lot of IP knowledge. We don't have a lot of IT knowledge as an industry. So a lot of folks are like, hey, I don't agree with that. But if you step aside from you or someone else's IT knowledge and you just look at the configurability of IP, it is much easier. So install, right? And that's one of the areas of speed. The other one that I'll be completely honest with you all, I'm not fully bought in on this yet, is data. So sharing data, being able to do trends, being able to pull data. The reality is with MSTP and data consumption, you can pretty much pull the data you need at the rates you need it. I mean, that's just the reality. Yeah, okay, back in the days when we had proprietary buses that were like 9600 baud, pretty slow. Yeah, then you had issues pulling data, but it was never really the communication buses that were giving you trouble with data consumption. It was usually the supervisory devices and the controllers themselves. They just didn't have the computing power to produce the data, and then the supervisory devices didn't have the computing resources to gather and store the data. That's largely been dealt with our modern controllers and modern supervisory devices. So I'm not fully bought into data rates and data consumption being a huge benefit of IP controls. However, you can transmit data faster. That's just the reality. Your refresh rates on data are going to be faster. Where this shines right here is moving into the advanced capabilities. So nowadays, a lot of these advanced controllers, so you see like Niagara is pushing the Niagara framework down to the edge in their edge controllers, which are IP based. And you're seeing things like graphical user interfaces, you're seeing things like schedules, you're seeing things like alarms and trends. Okay, I'm just going to put AL and TR for trends. You're seeing a lot of this being built in to the controller, and IP is allowing you to utilize that. See, if you tried to open, I don't even know how you would open a web browser on MSTP. I don't even think that would be possible. I mean, how would you even establish a connection? If anyone knows how you could do that, that's something I don't know, but I've never heard of it being done. So every example I've ever seen of someone opening a web browser from a field controller has been with IP, because IP allows you to utilize HTTP and TCP and all that fun technology stuff that you need to open up a web page. So if you're doing a central plant, or if you're doing a very expensive air handler at a hospital, and you want, in case that supervisory device goes down, or in case just some sort of catastrophic failure, you want that controller to be an all-in-one solution, then you can utilize IP controls, and this will give you all the benefits of having a front end, but it's built into the controller. And then finally, we're starting to see this a little bit, not as much as I thought we would be seeing by this point, but this is definitely where the industry is going, mark my words. Supervisory devices, your JACEs, your NEs, whatever you want to call them, they existed primarily to do protocol translation. So they would take a serial bus network like MSTP and convert it to IP, so that way you could pull it into a machine, at the time a thick client machine. Well, nowadays with IP controls existing, there really isn't a whole lot of need for a supervisory device anymore. The reason you haven't seen them go away completely is because the manufacturers would have to redo their entire framework for their building automation systems. But I'm willing to bet in the next versions that you start to see come out, you're going to start to see supervisory devices just start to disappear or just not be as important to the building automation architecture. Is this all making sense so far? Do you all have any questions on anything I've covered so far? Is this pretty much aligned with what you know about IP controls? This should not be shocking to anyone who's worked with them. This is kind of the default benefits of IP controls. And as always, you can go into the questions and go and type them there. All right, so let's go to the next slide here. All right, IP controls architectures. There's primarily 3 IP controls architectures that you are going to utilize on your projects. I like to call these patterns because patterns are things that you can implement again and again and again and again. And those are the star pattern, the bus pattern, and the ring pattern. So we're going to go through each one of these, and then we're going to start looking at our design process. Okay, so the star pattern, this is a single run. So if you have a cable modem at your house, it probably has 4 ports on the back of it where you can plug in an Ethernet cable. And if you connect an Ethernet cable from that cable modem to a TV, because let's say your Wi-Fi just doesn't have enough bandwidth and you're trying to stream 4K on your TV and you just can't do it, so you get an Ethernet cable. That is a star pattern. That is a single run from the switch on the back of your cable modem to the network interface card on your TV. Now, this is the most expensive pattern for 2 reasons. One, you're going to have to utilize a port per device. Depending on what kind of switching hardware you're utilizing, you could be spending anywhere from $2,000 to $10,000 a switch cost. So some layer 3 Catalyst Cisco switches are upwards of $10,000 for the most advanced models, and some are much less than that. So this is going to be very expensive for the cost. It's also going to be expensive for the wiring typically, because you're going to have to go from the switch to each device rather than these other patterns where you go from device to device to device. However, it is the most stable. I mean, granted, the switch is a single point of failure, but I mean, the switch is a single point of failure in all of these patterns. But if you were to lose one of the Ethernet runs, you only lose one of the Ethernet runs. If a port goes out, you only lose one device. This is most suited for large equipment, for equipment that you are saying, hey, you know what? This central utility plant or this large tonnage air handler makes enough sense for me to run directly from a device to this controller. You see this in cases where you get a spec that says, hey, our main equipment is going to be IP controls, but our terminal equipment is going to primarily be MSTP, which is where I sit. If you were to ask me my recommendations on IP controls and what I recommend as far as implementation strategies and just spec designs and things like that, I see the most benefits from using IP controls with a star pattern going to large pieces of equipment and then still utilizing MSTP for terminal equipment controllers, things like VAVs, etc. That's where I see the break. So let's look at the star pattern real quick. Pretty straightforward, right? You've got a router, you've got a switch, and then from that switch, each port goes and has a Ethernet cable, typically Cat5 or Cat6, from the switch port to the network interface card on the controller. Depending on the manufacturers, you could potentially be using something called Power over Ethernet, which allows the switch to provide DC power. I think it's up to 60 watts. I'd have to look at the standard. I mean, I will tell you, my philosophy on memorization is you can Google it. Maybe that's something to do with my generation, but why memorize something that you can look up? So as far as the PoE standard, last I checked was the Cisco version could do 60 watts or something crazy like that. And then the generic version, I think, was at like 40 watts, something like that. Okay, so pretty straightforward, right? Easy pattern, real easy to set up, real easy to wire and install. And the beauty of all these patterns are they're going to be pretty much the exact same from the logical design standpoint. They're only going to be different from a physical design standpoint. And I know that doesn't probably make sense what I just said right now, but I promise you by the end of this webinar, it will make sense. All right, so continuing along, bus pattern, right? Also known as the daisy chain. Now, prior to doing this webinar, I looked everywhere for recommendations on daisy chain limitations. I went and tried to look at IEEE standards. I tried to go and look, hey, Ethernet daisy chain. I went and looked at voice over IP devices. How are they handling it? And I found answers all over the place as far as limitations to the capacity of daisy chain. The general consensus is that daisy chain can handle a lot, but ideally you want to limit it to 32 to 64 devices per segment. Now that goes against what you'll see on some manufacturer catalog sheets, but when you're thinking about just troubleshooting, when you're thinking about laying out a network, typically you're thinking about laying out a single daisy chain run on a floor, typically in a vertically stacked building. And in that case, 32 to 64 devices is pretty reasonable. And if you have to go more than that, usually you'll split an east-west side, or maybe you'll quadrant it up into 4 quadrants on the floor plan, depending just on square footage. So the bus pattern, also known as the daisy chain pattern, we should all be familiar with this. It's no different than BACnet MSTP. Well, I guess it is a little bit different than BACnet MSTP, whereas BACnet MSTP is RS-485 with 22.3, so 22 gauge, 3 conductor wire typically. This is where you have Ethernet going from one controller to the other controller, and you are going from one port on a switch all the way down the daisy chain. Now, this is the lowest cost. You're only using one port on a switch. You are going to go from device to device, so your wiring costs are going to be lower, but it is also the least stable. If you lose that port on that switch, you lose the entire trunk. Additionally, and some manufacturers are starting to solve this, but not all, and this is a really good, for any of you who are owners or specifying engineers, this is a really good question to understand. I'm not saying it's a deal breaker because there's a lot of manufacturers who don't have this. I don't even have a list of who has this capabilities and who doesn't. But is to understand power decoupling. I don't even know if that's the right phraseology for this, but basically, if you lose power, then what happens at any controller on most daisy chain patterns is because the Ethernet is coming into one NIC, one network interface card port on the controller, and then going out another. If you lose power, then what's happening is everything downstream from that controller is dead. You can't read it. It's not like MSTP where you lose power at a controller and they're still electrically bridged, the wires are, and they continue on. Now, some manufacturers are building in a switch that even, a mechanical switch, a physical switch, that even if you lose power, it will still allow the signal to continue on. But that's not everyone, so that's an important thing to ask about. This is primarily used for terminal controllers. I would not recommend this for large equipment because of what I just mentioned. You don't want a VAV box losing power taking down your central utility plant. I do not recommend intermixing star pattern and bus pattern. Or I do not recommend intermixing large equipment and terminal controllers. Keep them separate in the patterns I recommend. It's a lot cheaper to pull a wire and pay for a port to IT than to have a VAV box take down your central plant in a hospital or in a drug lab or something like that, okay? And then finally, ring pattern, which we'll talk about in just a second. So bus pattern, pretty straightforward, single switch, port connects to the first controller, then goes out the next NIC to the next controller, and so on and so forth. Now, as I mentioned, this is typically 32 to 64 devices. Any questions so far? Anyone? Remember, you can use the question box. Just type them in, and my team will see them pop up, and then I'll get a ping and I'll know to answer questions. All right, so ring pattern. Ring pattern started in the industrial world, which, by the way, all of this started kind of in the industrial world. They were doing IP controls to industrial systems way before we decided to do IP controls to building automation systems. So whenever you get that kind of rejection of IP's insecure, IP's unreliable, et cetera, et cetera, et cetera, just realize that factories that probably have a much higher cost of downtime than any of our buildings do, except for maybe like a healthcare environment or an airport, they've been running IP controls. So that's a false argument of IP controls are cyber risks and all those kind of things. Those just aren't logical arguments when you look at places that are doing production runs where a single run loss can be in the millions of damages, and they're just fine utilizing these things. So ring pattern, right, it utilizes 2 ports. It's kind of a middle cost. It's not near as expensive as star pattern, but it's a little more expensive than bus pattern. Most of the cost is actually going to come from the configuration because, I mean, in reality, it's just one more port, whereas bus pattern is a single port. Ring pattern is 2 ports, and we'll talk about that in just a second. Now, what's going on here is that we have kind of a medium stability, right? We have medium stability related to this pattern, and that is because if one port goes down, the other port will take over, and we'll talk about that in a second. This still is primarily utilized for terminal controllers. So what that looks like, single switch, 2 ports, and what happens here is one port. This is where this concept called rapid spanning tree protocol comes in, and we're not going to go through that. Just that would take a whole nother webinar. But what that is basically it blocks one port in software from being open, and then you have another port that is open. And so that port that's open is sending traffic along, right? From controller to controller to controller, and the switch is sensing that that port's working. If that port fails, then the other port opens up and the traffic goes the other way. So this is a way of going and making sure that your communication traffic is always flowing. So it's more reliable than the ring pattern, right? But it is much less cost than the star pattern. All right, you all with me so far? Making sense? Any questions on patterns? Because we're going to leave that section, and we're not really going to cover that again until we have the question and answer session. All right, I'll give you all a couple seconds. In ring pattern, what happens when one device goes down? Okay, great question. So what would happen? All right, watch. If this goes down here and this right here, let's say this controller dies and it stops transmitting to all these. Well, what can then happen is that you can actually go and this, because let me talk. All right, I said I wasn't going to talk about rapid spanning tree, but I will just a little bit. Just a little bit, I promise. So what will happen with rapid spanning tree protocol is you've got this thing called a broadcast. IP addressing works by broadcast. That's how you discover IP addresses on a local subnet. The problem with having 2 ports open is a broadcast would go in circles for days. And you would get this thing called a broadcast storm, and it would take down your network, all right? So that would be pretty bad. So in order to stop that, you block a port. Now, what happens if this controller goes down, and this is really dependent on how the switch is set up and how the manufacturer has it set up, but most of the time what's going to happen is this controller goes down, this device, this switch is going to sense that, and it's going to sense that there is no longer a loop, and it will start sending traffic out the other port to the other devices. That's all about setup. It's all about manufacturer configuration as well. So validate that answer with your actual manufacturer and your IT group that you're working with. All right, so that's one question down. Let's take a look. Okay, can you mix and match patterns? On a single switch, you can mix and match patterns, okay? So on one switch, you can go and have a pattern, right, that is basically bus going out to controllers, and then you can have another port on that same switch going star. What you cannot do is you can't, and I don't even know how you would, you can't mix and match the actual architecture patterns. Does that make sense? Hopefully that makes sense, because what I'm saying is that you can't go and decide you have a ring and then, oh, I'm going to stop in between these controllers and make that a bus, because that would then make both of those a bus. So that should be pretty straightforward. Alrighty. Who owns what? IT owns the switch. We'll talk about that later in the webinar. So I'll leave that one up. Who commissions the BAS when IT is usually last? We'll talk about that later in the webinar as well. And what if controller 2 goes down? Does it communicate with both sides of the ring? I think I kind of answered that. It will notice that that is ending. Once again, this depends on switch setup and this depends on manufacturer setup. But it will notice that that loop is ending and it will open up the other port most of the time. I'm not giving you a definitive answer on that, because some folks are using MRP rings, some folks are using just a basic ring technology. There's different types of ring protocols, and how they fail over is something you really want to talk to the manufacturer about, how they handle failover. All right. Good. Those are good questions. I freaking love those questions. That's awesome. All right. I'm going to take a sip of water and we're going to go back into decoding controller capabilities. So this is really hard, right? So you get something that looks like this. This is the Honeywell, what is this? Their Cyper 30. And you get something like this and you have to figure out, how do I deploy this on a job? How do I design this rather for a job? So as we start to look at this, here's kind of where I start to focus in on, right? So I'm going to just tell you where I focus in on. Excuse me. I don't care about that. So I'm not going to care about that right there. So I see, rapid spanning tree. We just talked about that, right? So now you're seeing why I'm talking about RSTP, rapid spanning tree. Daisy chain, okay, we know what that means. In a redundant ring, we know what that means. Star network topology, we know what that means. So we've just identified what? What have we just identified? That this can handle the 3 protocols or the 3 design patterns that we've went through so far. So we see that not every manufacturer's controller can handle each design pattern. So that's the first thing we kind of want to figure out, right? Is these design patterns. We also notice that this thing has a 4-port switch. So what does that mean, right? We can have cameras and things like that on it, which we may get. Folks, remind me on this, because I don't have this built into the slide deck. We kind of, when we do webinars, we lay out the webinars, but sometimes stuff pops into my head as we're doing them that I realize is important for you to know. So quality of service is something that we really have to start being concerned with IP controls. So if I forget and we have enough time left and no one's asking questions, remind me to discuss quality of service, because this is something I'm not too fond of, is going and saying, hey, we can hang IP cameras that run 4K video on our 4-port switch and route it through our, I'll talk about why. Okay, so that, all right. Not really seeing anything else. Okay, we see TCP connectivity with Cat5 or Cat6. I mean, that's to be expected, right? If we're going to do HTTPS or HTTP, we have to be able to utilize TCP IP. And of course, we're going to have IP connectivity because we're using IP controls. I mean, that would be kind of weird to have IP controls without IP connectivity. All right, so let me erase all this and let's go to the next slide and kind of talk through this. All right, so let's dig a little deeper here. We see, right, we have the IP switch. Okay, that might come in handy if we want to do some star patterns off this controller. I'll talk about why that might be a good idea and why that might not be a good idea. And then we see right here, 200 plus controllers on the daisy chain bus with fewer home runs for faster, lower cost wiring. I told you it's, it's hit or miss. I went and looked this up and I didn't get a clear answer as to the actual device capacity on a trunk segment. I will tell you that I would not feel comfortable with having 200 controllers on a trunk segment for the reasons I covered in the bus architecture of failure points until manufacturers address that. And then we can see right here with the redundant ring right around 40 controllers, and then supports star network topology. So we know what it supports, right? And then here we're looking at understanding a little bit more, and what we see is that we have IP connectivity. I mean, that doesn't really mean anything to us. We should already assume IP connectivity and Cat5 and Cat6 cables because, I mean, we're doing IP controls, and we see some stuff around HTML servers. So what we need to do at this point, right? So we've went through the catalog sheet. We know what design patterns, what architecture patterns we can utilize. We understand what each pattern does. It's at this point that we need to start working through the design process. And the design process works like this. And this is, I'll talk about where I see folks mess this up. I'll talk about kind of how this works and how this doesn't work, and we'll actually, in step 4, we'll build our design. So step 1, we've got to get a device count. We need to know how many devices we're dealing with. So for our scenario here, we're going to do IP controls everything. Once again, remember, I am on the fence about using IP controls for terminal equipment, but just to make this more interesting, we'll do IP controls everything. So in order to do that, right, I'm going to bring up a mechanical set of prints, and I'm assuming you all know how to do takeoffs. So I'm assuming you all know, go count the boxes, understand what devices you have, pay attention to the notes, and then go all the way down to the equipment schedule. Validate that the equipment schedule matches up with your floor plan count. And so we see, right, we got 25 VAV boxes, 1 through 25. We have a couple things up here, not really anything we're going to be controlling. We have some fans. Most likely these are going to be hanging off of existing controllers, so we're not going to have to worry about a dedicated controller for those. Got an air handler, got a fan coil, and then we've got a BACnet IP chiller. Okay, so seeing all of this right here, we've got 1, 2, 3, and then 25. So we've got 28 IP control devices. Right off the bat, we can figure that we want to use our bus pattern most likely for our VAV boxes. Now, you may be saying, Phil, when do we decide if we want to use bus pattern or ring pattern? It's really a tolerance of failure discussion because, I mean, technically we're in the design constraints for either pattern, right? We could do a bus pattern and we're 25 devices, so we're fine. Or we could do a ring pattern. We're under 40, so we could do that as well. It really just depends on our tolerance for failure. This is a school, so it's not really a critical environment. Now, on a hospital or something like that, you may decide that you want to do ring. So look at the spec, understand if the spec is asking for ring or bus. And if it's not clear, you can either go and do an RFI and say, hey, which one would you like me to use? And then you can make your recommendation based on the actual criticality of the site. Or if you don't want to do that, then you can make your own best judgment call. I would typically recommend just submitting an RFI because at least that way you're getting contractual direction and you're avoiding them coming back later and being like, oh, hey, by the way, this should have been ring instead of bus, which isn't that huge of a deal. I mean, it's one pull, but it's still one pull that you didn't price. All right. And then, as I mentioned, for our equipment, we'd probably do a star pattern. I'm on the fence about fan coils, whether we do a star pattern for that or not. It's kind of hit or miss. Since it's one, I'd probably just do a star pattern for that, especially because it's probably cooling an MDF or an IDF if I went and looked at it. So it's cooling a data closet most likely. and then star pattern for our AHU and star pattern for our air-cooled chiller. So we know we have 28 devices. We know we are going to need, at a minimum, right? We're going to need one port for the bus and 3 ports for the star, and probably a port for our supervisory device. So we're looking at 4 plus 1 more, so that's 5 ports that we're going to need from IT. And we know that we have 28 devices. Excuse me, let me take a sip of water. I've been talking a lot. We know we have 28 devices, so we know we're going to need 28 host IDs. Okay. So once we've done that, and this is why you do this first, because what we're going to do is we are going to go and talk with IT once we've got this device count. Because if we don't have the device count and we initiate a conversation with IT, I mean, most of us are uncomfortable talking with IT in the first place. That's gradually changing, but coordinating with IT without having all your facts and knowing exactly what you need is just going to create a headache for you. So get your device count down first and then coordinate with IT. So I got one question about why using a star off a ring. And I talked about that I would mention whether that's a positive or a negative. So here's the deal. We're running an air-cooled chiller, a air handler, and we're running a fan coil unit. Now, if I technically, if we're using that Honeywell controller with its 4-port switch, I technically have 2 ports left, right? Because we're using a bus or a ring. And so I need 2 ports for each controller. So I could go and off of one controller, I could do the fan coil, off another controller, I could do the air handler, and off another controller, I could do the existing air-cooled chiller. I could pull those in. But here's the deal. That violates the whole point of a star pattern, because the benefit of the star pattern is not, hey, the controller's closer, so I'm going to pay a little bit less in wiring and I'm going to have one less port that I need to request from IT. The real benefit of star pattern is that now I've decoupled myself from that ring or that bus. So if that ring or bus fails, my air handler is still running. My chiller is still broadcasting information. So my recommendation is that on large pieces of equipment, utilize a star pattern directly to a switch, because I get what they're doing by including additional ports, but I would recommend utilizing those additional ports for ancillary equipment that is associated with the space. Like maybe you've got a light that you're using IP with and you want to connect to that. Or maybe you've got a local screen or something. I'm pulling things out of my head right now. Or a camera, as they mentioned. Those are things that if that particular device fails, it's not the end of the world. But if that controller fails and all of a sudden you lose the air handler, that's a much bigger deal. So hopefully that made sense, my reasoning of why I would not recommend starring off of a ring or starring off of a bus for these types of pieces of equipment. All right. Okie dokie. So let's continue. Coordinating with IT. All right. So we go and we talk with IT. This is something in our IT course we talk about a lot. And I think I've got a webinar on YouTube that I talk about this as well. But essentially with IP, you just need to use the question, what needs to be true for you to give me X? So in our case, we know we need 28 IP devices. We can utilize DHCP or static IPs depending on our controller and how it works. Once again, IPs, DHCP, static, all that stuff was covered in the video that I sent out to y'all. So if you don't know what that is, I recommend you refer back to that video after this webinar. So we coordinate with IT and we tell them what we need, and they give us something like this. They say, hey, here you go. We're going to give you a subnet 192.168.1.0/26. which that gives us 64 IP addresses to work with. One goes to our default gateway, one goes to our broadcast address. That leaves us 62 host IP addresses that we can continue to work with. So it's at this point, right? It's at this point that we decide on an architecture. Now, as I recommended, we would probably use a star pattern. Actually, we would use a star pattern. I'm going to make an executive decision here on the chiller, on the air handler, and on the fan coil. And then on the VAV boxes, since it's a school, we can just use a daisy chain. And all we have to do is lay out our design working from layer 1 to layer 4. Now, some of you are like, layer 1 to layer 4, what the heck does that even mean? All right, so let's pull up this right here. Let me grab my handy dandy pen, and we're gonna talk about layer 1 through layer 4 real fast, like probably less than 2 minutes. And then we will go through the design because I'm realizing it's 11:40 already, and we still have to get to deployment. Actually, you know what? I'm not gonna go through layer 1 and layer 4. I'll talk through it as we go because otherwise we're gonna run out of time. So from a architecture perspective, we're going to have our router, which is going to be an R, okay? And we're going to have a switch, which is going to be an S. And each switch is going to have a port, and we're going to coordinate with IT and find out what ports they want us to use. And then on our drawing, we are going to have a table, and it will have the device, right? It'll have the IP address, it'll have the port, and it will have the pattern. Although the pattern should be able to be inferred by the electrical who's installing all of this, but that's what we're going to do. Device, IP, port, pattern. That's going to be, it's like a bill of materials, but it's actually a network list. Okay, so then, and that's what you do when you're designing IP networks, by the way, for some of you who have never designed an IP network before, you have a list of your devices, your IPs, and sometimes you'll even have your MAC addresses and any other pertinent information as well. So we would lay out, right, from switch port 1, this would go to our chiller, okay, so CH, and then switch port 2, right, we would go to our AHU, and so on and so forth. And we would assign an IP address, and it's not going to go on the drawing. I highly recommend it goes up here into our device list, and we just simply number. We come up with some form of numbering, whether it's an ID number, whether we're using a BACnet, device ID, whatever ID identifier we want. Because if you start putting IP addresses on your riser, it's going to get really messy. Keep them in a nice organized table, typically in the upper right-hand corner. That's where most folks are comfortable. Sometimes in the lower right-hand corner if you so choose, but I typically recommend up here because that's kind of right where the eyes go to. And then we go and lay out our bus, right? So from controller to controller. And what I recommend you do here is that you look at your mechanical drawings and you figure out where is this switch going to be sitting. Usually it's in the IDF or MDF. So if we go back to our drawings, we can find, right? Let me clear this off real quick. Erase all that. Go back to pen. Here we go. And if we go back to our drawing, we can see that we are going to find most likely an IDF or MDF somewhere around here. So we've got an electrical closet. We have a tech closet somewhere in here, I know, because I've looked at this set of drawings before. Telecom right here. So our switch is going to sit in here, and then we would just start from our switch and move to controller to controller to controller. All right, pretty straightforward. Now I know I cleared all that off, but what you want to do, and give me 1 second and I'll get to your question. But what you do, right, you lay out the router, you lay out the switch, we have our table up here, right? This is our network table. And then our architecture is going to be down here, okay? So that is going to be our topology, our network topology that we'll draw out. What we want to do from that point, okay, is then we want to go And we're going to go back to our right here to our presentation. And we're going to go and lay out that design as we just did. And then we validate it with IT. We're going to go to IT and say, hey, this is our design. These are the ports we're thinking of. These are how we're going to lay out our IP addresses, whether we're using DHCP or static, et cetera, et cetera. And once we validated that, we then can submit that design. Now, that brings up a whole ton of issues that we'll talk about in just a second, which are specific to when you're on a construction project and IT is not even on the job yet. But before I do that, I'm going to take a look at the questions that have popped up. Is the network coordination table to be created by the plan spec engineer or controls contractor? Controls contractor. I can't think of a scenario except for where there's a technology contractor who the controls contractor maybe is reporting to, where that network table would be created by anyone other than the controls contractor. Just purely due to the fact that most controls products have a different way of whether they're static or dynamic or all that stuff. It's so different. I couldn't expect a plan and spec engineer to have all that memorized. Next question. What's a good reference if I want to verify a system is being properly installed? I work in the airport, only maintain, it's not installing, but I want to be educated enough to spot poor installation to stop further issues. I want to have troubleshooting of problems quickly also. That is a large question. Let me try to answer that towards the end because that has a lot of different variables. And I feel if I open up that question, I probably won't get through the rest of the webinar. But you can stick around even after the webinar ends and I'll take all the questions everyone has. All right, so we went through creating a design. And now we move on to the topic of IP controls deployment. I'm just going to skip over retrofit because if you are doing a retrofit, you have an IT group, typically with a network in the building, most likely. Granted, I realize some commercial properties don't. They use outsourced IT, which is a whole nother can of worms. But we're going to focus in on new construction. How do we deal with new construction, especially since IT is usually going to be the last thing onto the job site? And quite often, the general and the mechanical really don't want to let us talk to the customers. So because of that, how are we going to coordinate any of this? How do we deal with this? Well, the main challenge up front is commissioning all of our controls, making sure they all communicate, making sure they all work. Because in order for us to do that, we've typically thought, hey, we need IT, we need an IT network. Well, fortunately for us, there are industrial solutions to our problem. There's things like the Cisco IE2K. So if I bring that up on the Google here, IE2K switch, which may be discontinued. But this is just a basic industrial switch. You can see it right here. These can go out on jobs and they are tolerant, not impervious, but tolerant to dusty and just construction environments. And it's here that you can go and connect. And Cisco is just one type. There's many other types of industrial switches. But what you do is you have these actually, either you charge them to the job or you keep them in your business, depending on how many IP controls jobs you do. And you put these on site and then you connect everything up to them as if they were a customer switch. And because we're using IP controls and because we're not going to be doing a whole ton of star pattern, most likely, what we can do is with a solution like this, we can go and have our rings come out of the ports. And then if we do need to do a star pattern, let's say we have a lot of air handlers, we could run a unmanaged switch out of one of these ports and then connect all our star patterns into that. This is solely to host a network long enough to commission the building, make sure everything's mapped in, And then when the customer comes along and actually gets their IT solution in place, that is when we would go and we would coordinate with them to switch everything out. Now, the other question usually is, okay, Phil, I'm going to do that, but I'm going to run my cables to these IE2Ks and or whatever industrial switch I use. And then when they put the switches and racks in the IDF, I'm going to have to rerun all my cables. Well, yes, this is no different than if you know you're going to be doing a TI and you know that there's going to be controllers somewhere. So you string up some MSTP cable up in the ceiling, and then you go and you later extend it to wherever the controller is. So what you typically do is you put the industrial switches in the IDF or MDF, and you'd have enough slack in your Ethernet cable. So this is where you have to direct your electricians. You'd have enough slack in your electrical or in your Ethernet cable that at a later point, once the switches are established, you can disconnect the IE2K. You can run the wire or run the Ethernet in the cable tray and run it to the switch. That's kind of how I would approach this. The biggest challenge here is just getting through commissioning and functional test and not being someone who's causing the certificate of occupancy to be delayed because of your IP controls. So let's take a look at some more questions. And folks, I love your questions. This is awesome stuff. I hope you're enjoying this. It looks like you all are. So is there a scenario where dynamic IP addresses would be deployed for BAS host devices? What are the pitfalls we need to be aware of? I'll take that in just a second, Brian. Let me back up to who owns what. IT owns the switch and BAS owns the wire and controller. Yes and no. Excuse me. So IT may own the switch. If you're doing an IT network, if you're doing an OT network, which is an operational technologies network, and you're putting in your own switches, you may own the switches. I've also seen scenarios where the industrial switches were left in place and just mapped into the existing IT switches. So it really just depends. And this is why I tell folks all the time, you really got to get comfortable with IT networking and switching and understanding how to utilize routes and switches and VLANs and ports and all that jazz, because this is where the industry is going. Yeah, granted, there are still reasons to use MSTP right now, but in a couple of years from now, the beauty of business is that the price of these products are going to start to go lower as their development costs get absorbed and companies can make more profit. So we're going to see that the price of IP controls is going to continue to decrease. So who commissions BAS when IT is usually last? I hope that I just answered your question on how you would handle that. If I did not, by all means, please go and ask it again if you need more clarity on that. All right. So dynamic IP addresses deployed for BAS host devices. What are the pitfalls we need to be aware of? So this used to be a really big issue, right? Especially with supervisory devices. And the reason behind it was, excuse me, was BACnet and how BACnet handles IP. If we had a supervisory device and we were using DHCP and somehow it got assigned to another subnet, and the routes still allowed, let's say we had a couple different IP address pools and we were pulling from, and we switched there, then sometimes that would cause issues with the BBMDs and BDTs in BACnet. Additionally, a lot of devices, supervisory devices and such, did not support domain resolution, which DHCP is Dynamic Host Configuration Protocol, but it is often paired with DNS, which is domain name services. And so DNS allows you to assign a name instead of an IP to a device, so you could type in the name of the device. And there were all sorts of wonky issues about supervisory devices supporting dynamic addresses versus static. And so we would always say, hey, you need static IP addresses. Nowadays, pretty much every device out there supports DHCP. I don't want to say every because I'm sure I will get messages saying, well, Phil, what about this thing that you've never heard of made somewhere that doesn't support it? But most of them support DHCP nowadays, modern solutions. So it's not really something I worry about that much anymore. It's also another reason why I do not recommend having 200 devices on a subnet. Why I recommend keeping your subnets 32 to 64 devices. Because if you're doing Wireshark or just like Angry IP Scanner and you're trying to find devices, you're going to run into a fair bit of issues when you have 200 plus IP devices popping up. It just becomes kind of a nightmare. Okay, so why would I choose MSTP over IP? Because it's cheaper. I can hire a lot more people who know how to troubleshoot it, wire it up, and support it. And I don't have to train my staff on troubleshooting IT issues really, because I mean, I'll just pass that on to the IT group. I'm being completely blunt with you and honest. Like, that's what a lot of folks think. But the primary reason is cost. MSTP controllers cost less, at least right now for most of them. And most of the time, we don't need them at the terminal equipment level. However, I see tons of benefits for IP controls at the equipment. So question came in, MSTP systems are proprietary. Well, let's talk about proprietary because I feel like that's a largely misused word. So proprietary, MSTP and IP controllers are quote, quote, proprietary if you require a separate programming software set for the controllers. That's where the proprietariness comes into play. MSTP is a completely open protocol. You can go and buy the ASHRAE, whatever 2016 standard, and write an MSTP backnet stack. I myself have written backnet stacks in code. So you can do that. There is nothing proprietary about that at all. The proprietariness is in the software to configure the controller. And that's why you see folks like Niagara pushing their stack down to the field controller, and you see other manufacturers trying to use a universal tool for configuration. But I mean, you could even argue that Niagara is proprietary and that unless you have the Workbench software, you can't configure a controller. It is not like it's JavaScript and HTML and C# where I just grab an IDE, an integrated development environment, I connect to the controller, and I can immediately write code. You still need manufacturer software for all of these solutions. I think there's Project Sandstar out there that's kind of decoupling from that. But yeah, so hopefully that clears up around proprietary and MSTP and IP. Alrighty. What are the use cases to use fiber optics instead of Ethernet, along with fiber optics, Ethernet converter to be terminated on the controller? So don't get too caught up that it is fiber optics or Ethernet. And honestly, I thought about starting this whole webinar with a discussion on IP, right? So IP is Internet Protocol. It is a logical protocol. It is not Ethernet. It is not Wi-Fi. It is not fiber. It is not 5G. It is IP. All of those things I just described, fiber, Ethernet, wireless, 5G, can all be delivery mechanisms, transport mechanisms for IP traffic. So fiber, you could route fiber multi-mode or single mode into a converter and plug it right into a switch port. You'd be perfectly fine. It's just converting the signaling. That's all it's doing. It's still IP. When you would use that, goes back to, you use single mode for long runs and you use multi-mode for short runs. Fiber is not really needed with IP controls because we don't have a lot of bandwidth going across, or data going across our trunks to require that. Okay. IP gets us closer to fully open competition in IoT devices. I would say that can be true to a point. It is definitely easier for developers to develop software that interacts with IP network traffic than MSTP network traffic. I will agree with that. But until manufacturers agree on a common software set that gets distributed to every controller, which I don't see happening any time in the foreseeable future, we will still be dependent on manufacturer software. Everyone does MSTP differently. The business side of MSTP is proprietary. Yeah, kinda, sorta. I mean, MSTP as a signaling profile or protocol is pretty much implemented. If you want to be BTL compliant, you've got to have at least the common services and objects implemented. I don't want this to turn into a BACnet conversation because we'll be here forever. But I can understand that, but it's not like we're talking the old N2 S buses, those kind of protocols that were completely freaking proprietary that you couldn't even get the source code or anything to design off of. All right. So with scenario, we talked about that one. Wood commissioning, we talked about that one. Would you configure a network using NAT? Okay, we'll get to that in a second. If you're going to send the recording of this webinar, yes, you all will receive the recording of this webinar. Okay. 100-meter max length for Ethernet cable. What is ring in thousands of feet? Yeah. So as far as the max length on ring, it depends on what protocol, what signaling protocol is utilized, because the 100-meter max length for Ethernet cable is still going to apply for ring, right? You can only do ideally, 100 meters, 300 feet between devices, and then you start to have signal degradation. That's why. But as far as ring goes, that is more about the signaling protocol and how that works. That determines maximum length. How much does security certificates play into IP devices? If we get a site that has a strong IT department, it's not like IP devices on their network. Have you had any experience with the difficult? Yes, I've had many experiences with difficult IT departments. IP controls are no different than them putting a bunch of IP devices on their wireless. I mean, it's the same logical architecture, right? And here's the thing. This is what I always argue when folks are like, well, someone can go hack into the device and access the network. Well, they can do the same thing with wireless, but yet you let people walk around because it's convenient and it supports the business objectives. So you have to have a business leader in that business saying this supports our business objectives in order to get IT to engage, because IT's purpose is to support the business. That being said, yeah, okay, you could plug into an IP switch and on one of these devices and potentially hack through it. Yeah, the bigger issue is that you've got someone on a ladder in the ceiling, or you've got someone in the mechanical room and you're not paying any attention that they're in the ceiling messing around with your controllers. I would say you have a physical security issue way before you have a network security issue. With that being said, a lot of these manufacturers do support a lot of security at the port level, as well as certificating as well. So they definitely have that. Talk to your manufacturers and they'll be able to tell you about that. How long do I think it'll take for controls devices to become a commodity using IP controls? At that point, will BACnet become obsolete? I don't know if BACnet will necessarily become obsolete as much as it will become a web service and will be less dependent on BBMDs and IP addressing, and all of that will become irrelevant, and we will use web services and we will have web endpoints and things like that. That's where I see BACnet going. The biggest issue that BACnet solves, that IP, HTTP, all of that, can't solve is strong data typing and strong service definitions. See, here's the deal. Let's say we got rid of BACnet today and we all switched to MQTT, or we all switched to HTTP. The problem with that is you have to get consistency across every manufacturer adopting the same services, and that means they have to have the same code base or similar code base to execute the same functions, like read property or write property service or create device service. And they have to support those. And the problem is that HTTP, MQTT, CoAP, all those protocols, they are not meant to have you can build services on them, but they are not meant to have functions built into the protocol requirements. Hopefully that makes sense. I know we're going a little bit into the CS world right now, but I hope that helps. What if the total run is long? I really can't answer that because it is dependent on the manufacturer. I can't tell you how long is too long on a ring versus how short is too short. That is something you just have to ask your manufacturer on. Okay, how would I configure a network using NAT to create an internal network when only provided one IP with IT? How would I make network discovery work? This is no different. So the bus topology, let me go back here, actually to Visio here. The bus topology is no different logically than a LAN, all right? So just because you have this, right? Controller, physically, you physically have this, right? Logically, meaning to the software in the switch, it looks like this. It looks like each device is individually connected. So the NAT appliance, network address translation, would sit inside the switch, and it would be no different than if you were taking a subnet, right? And you were utilizing NAT on that physical subnet. The only difference is the physical layout is different. Logically, it's the exact same. Hopefully that helps. I find that when folks start to realize that logically, a lot of our architectures are exactly the same as a normal LAN architecture, that's when this all starts to click, because we get so caught up in these different architectures and we're like, man, it's so freaking confusing. How would I apply this NAT or DHCP or MAC address security? How would I apply this to this different architecture? When in reality, the switch basic normal physical LAN architecture, it's no different to the switch. Hopefully that makes sense. Do I have any plan for a webinar for BAS command centers and how we benefit from IP controllers? So after this webinar, you're going to get a survey when you close the webinar. I think that's how it works. I would recommend that you, if you have a suggestion for a webinar, just type it in. We're always looking for feedback, and I definitely appreciate ideas on how we can continue to bring great webinars. I hope you all are leaving this like, holy crap, this is like no other webinar I've actually been through where, you know, someone actually told me something unbiased and actually gave me something I can leave the webinar today and go apply to my job this afternoon. That's what I hope you're coming out of this with, that experience. What determines the number of VLANs needed for a BAS implementing IP controllers? Okay, so let's talk about, and I highly recommend, if you haven't viewed that IP video, that you view it, because I think that that's where this answer is stemming from. So a VLAN, right? A VLAN, the sole purpose of a VLAN initially, right? Let's say that this is a horrible drawing. I'm going to restart this. I'm not known for my artwork, so if you come in here for artwork and you're like, oh my gosh, this guy looks like a 6-year-old drawing, that's just how it is. But you have a building, right? And you have an accounting floor. I'm giving you kind of the old how we used to teach VLANs. Accounting, you've got sales, and then you have ops. The sole purpose of a VLAN is to take a single switch with multiple ports on it and then to segment the traffic logically. So this single switch now, which physically looks like this, actually looks like this, right? It looks like 3 different switches because we have 3 VLANs. Even though physically there's one switch, logically it looks like 3 switches. Now, so to answer that question, what determines the number of VLANs needed for a BAS implementing IP controllers? It's all about your architecture. So typically you're going to have one VLAN per, I would say, 128 to 256 hosts. Okay. Now, granted, you can assign the same VLAN, if I remember correctly, and I'm going back here on my memory. I may be giving you the incorrect answer, so just double check this. But if I remember correctly, you can assign the same VLAN to multiple subnets. I think I may be mixing that up. But what I typically recommend is that you have a VLAN for no more than 254 devices. And you can group them, so you can have a VLAN for floor, and that's a virtual LAN. But here's the thing, right? Here's the deal. The whole purpose of a VLAN is to allow a physical LAN to stretch across multiple switches, or to allow multiple single switch to have multiple logical LANs. Now, I know this is a poor explanation, and I'm telling you that the video I shared with y'all does a much better one because I'm doing this on the fly with this really bad pen thing I got going on here. But to answer your question, it all depends on the physical architecture, building layout, how you want to segment logically and physically your IP devices. So hopefully that gives you an answer. All right. Would commissioning of networks be the same group as commissioning HVAC equipment? That really depends on the way that the contracts are structured. So if the mechanical is commissioning, let's say you've got a smart, actually I should clarify that. Are you meaning like, hey, I've got a Train rooftop unit that has a BACnet IP card on it that's being pulled in, and the mechanicals commissioning that, and then the controls guys are commissioning a bunch of controllers? Or are you talking about just overall? Because overall, the network is going to be typically configured by IT, who is then going to give you settings, and then it is your responsibility to set those settings in the actual controllers. So whoever owns those controllers is usually who has to apply those settings. Yeah, that's what I thought. Robert said you can have multiple subnets for a single VLAN. That's what I thought. It's just, you realize as you get older, as I am, that you forget more than you remember. So this is how it is. So what connects MSTP to IP? That's typically a supervisory device or some sort of protocol gateway. So one of the people says, I think the network design should be the engineer's responsibility, not the controls contractor. I don't agree. I respect your opinion, but I don't agree because the controls contractor is going to be servicing the site. typically after the building's built, and the engineer is usually not going to be related to the project. I mean, granted, a lot more engineers are starting CX groups and they're starting remote operation centers, but typically they are one and done. They're off the job, and the controls contractors aren't. And so those folks need to really understand. So on plan and spec work, I would say it's a controlled contractor. Now, if you get to integrated project design or P3 projects or design build projects where you have like a technology contractor, yeah, in that case, I could see that technology contractor overseeing network design, especially if they are the ones sourcing the switching providers. So, like all answers, there's no end all be all. So it says another way for controls contractors to lock in the job. Well, there are so many ways that you can lock in a job as a controls contractor that I wouldn't be betting on locking in the job on my IP network design, because I mean, IT can just simply go and do a scan and of their switches and say, hey, here's the layout. I mean, there's software that'll do that in 30 seconds. If I was a contractor and I wanted to lock everyone else out of the job, then what I would do is I would go and I don't even know if I should tell you all this. um, there's things I would do and it wouldn't be related to the network. So if I had 32 controllers, could they each be 100 meters apart, or are we focused on 32 TCs? No. So it's 100 meters apart each one, as I understand the daisy chain standard. So hopefully that makes sense. Now, to throw another wrinkle in there is when you start to have switches. And these, because see what's going on with most of these are they are just passing through the IP traffic. And they're just reboosting the signal, processing it, reboosting it to the next controller. When you start to have switches into the effect, you can only have like 3 or 4 switches in a row. I think it's the 3-hop rule or 4-hop rule, if I remember correctly. And that's where things get a little messy. You need to address all of the issues to enable open competition. To be completely honest, when I look at competition, what I look at from folks is I look at their sales people, their ops people, and their service people, because all the products are pretty much the same. I mean, they have little nuances here or there. And whoever you decide to go with, you're pretty much going to be stuck with them for 30 years, product wise. Software wise, there's ways of getting everyone's software. You just have to be creative. And really, once you learn software, once you learn one product, it's super easy to learn another product. It's just learning your first product, because at the end of the day, they're all pretty much the same. They're a little nuanced here or there, but I mean, with a little bit of time, you can figure it out. I've done it time and time and time again. I mean, you could just go and call parts numbers, and there's distributor or the parts number at the large OEMs and buy direct from them. And there's distributors all over the place as well. In this day and age, it's a lot harder to keep stuff locked down. How do we monitor all the BASs from different vendors in a single platform like Cisco Jasper? Sorry. Man, all right. Who will be responsible for extracting data from BAS to the IoT platform, and how do we do that? I mean, you guys have some detailed questions. All right. Okay, so we've got 2 really detailed questions here, and it wouldn't be fair to Jim if I answered your question first without answering his very detailed question before that. So Jim's still here. Cool. All right, so what is a good reference if I want to verify systems being properly installed, work at an airport, only maintain the systems. I'm not installing, but I do want to be educated enough. Spot poor installation. Okay, I want to have troubleshooting. So of problems quick also. First thing, as an owner, create a building standard. You don't have to do it from scratch. Google building automation. Like seriously, I think we could do this while you all are on the call. We're so going off topic here. Um, it's okay though. Let me erase all drawings. Building automation standard. Site edu. There we go. So you type in building automation standard site edu, and it's going to give you so many different ones, and just take whichever one you like. Get it applied throughout the enterprise, and then hold people accountable to this. That is the easiest answer to your question. Because if you don't have standards, I can give you so many different things you could check, but you can't compare them to anything unless you have standards. So that's what I would do. I would go and create a standard. And by creating the standard, you then have something that is the standard. They have to perform to the standard. And if they don't perform to the standard, then you can hold them accountable to that. That is what I would do. Now, troubleshooting problems quick. That is, we'll do a webinar on troubleshooting. I think we'll do a future webinar on troubleshooting. I think that'd be valuable. I'm not going to address that here. Okay. So single platform like Cisco Jasper, who will be responsible for extraditing data. Okay, so let's look up Cisco Jasper. Control Center. All right. This is their latest product. Manage a bunch of IoT devices. Pull them in. Okay, so first thing we'd have to know, right? We'd type in Cisco Jasper. Protocol list. Let's see what protocols they support. So that would be the first thing. I'd want to understand what protocols do they support. Once I understand the protocols they support, then I would go and I would lay out. So I'd lay out the protocols that I have. Then I would create a consistent data taxonomy. So what am I going to name things? So I have consistent naming. And then it's just a matter of if they support BACnet IP, pulling it in. I know I greatly simplified that, but if they don't support BACnet IP, then, I mean, that's going to be a headache because a lot of manufacturers do not support RESTful APIs. So I don't see anything about BACnet with them. So you're going to have to find some way, most likely, to convert them. Let's see, BACnet. Do they support BACnet? I'm not seeing anything on it. So you're either going to have to create a service that consumes BACnet, or that consumes BACnet and takes it into an API form, or you're going to, well, they have Modbus RTU. I'm just not seeing anything about BACnet. I'd have to read more on this. This is Oracle, and they're talking about their list. So I'd have to dig into this more than I would have time to do on this call. But that would be what I would look for, right? I'd find a protocol, either through a protocol adapter or a protocol they support to pull it in. I would create a data standard that would have to be applied across each BAS. And then I would go and have a MSI or a technology contractor who would be responsible for coordinating those between the different manufacturers. And then I would pull all that in. Now, that is a very simplistic answer to a question. If you want to know more about that, go to here. Building automation monthly system integration guide. Read this. It's like 46 minutes to read it. It's like 10,000 words. I would recommend, I mean, you go through this, it's going to tell you basically everything you need to do. So, all right. What else? I defined why the design should be the engineer's responsibility to meet the standard. Well, yeah, I agree a design to a point should be an engineer's responsibility. I think they should specify the intent, while as the execution should be designed by the contractor. That's the whole point of submittals. Now, that is completely different than standards, which so many owners do not have standards. It's amazing. So I feel for consulting engineers who have to design and they don't have any standards of which to hold things accountable. So Div 25 specs and design drawings to enforce the standard, including network architecture drawing. Yes, if the contractors support Div 25. That's a whole nother conversation of getting Div 25 implemented. You primarily have to have a different construction delivery model than plan and spec in order to best utilize Div 25. All right. Any other questions? I think I've gotten through everything. Was this helpful to you all? I mean, there's still a fair bit of you all here. So hopefully this was helpful. I know we've went 30 minutes over the time span. But hey, I told you all I would stay around. So glad to have you all here. And as always, remember, these are my opinions based on my professional experience. Oh, yes, you reminded me of quality of service issues. Yes, thank you. Thank you. I told you to remind me. Perfect. Okay, so quality of service issues. So a lot of us in the industry don't understand what quality of service is. Well, quality of service, right? So basically quality of service, think of a switch as a tunnel, right? You've got a tunnel going under the water and only so many cars can fit in the tunnel and go through at a time. Well, what happens is that let's say an ambulance has to go through the tunnel. It gets priority, right? I mean, it's an ambulance. It's got to get through, okay? And I realize that you're going to have to go with me on this because this is going to be a little bit wonky of an illustration, but just bear with me. So they stop all the traffic going through and the ambulance gets to go through, okay? That's because the ambulance has a higher priority or quality of service than all the other traffic going through the tunnel. Well, when it comes to network traffic, especially 4K video, 8K video, things that are high bandwidth hogs, they use a lot of data. And especially video, which is streaming, so it's constantly sending data. So it's not just sent and done, it's constantly sending data. So what happens is building automation data doesn't have quality of service typically associated with it. So if you start to overload a trunk, a network trunk, which we're not talking about field buses and trunks, we're talking about a trunk, which is a connection between two switching devices or two routing devices. If you start to overload that trunk with data, what's going to happen is now you are going to have an issue in that the switch is going to start dropping data. And what data is it going to drop? Well, the data that has no quality of service tag, like building automation data. So you'll see this in data centers where they're doing massive data updates at night and the BAS starts to go offline. And so that is one of my biggest issues with putting cameras and other things on a BAS network is that the quality of service is not being properly addressed right now, and we're going to have BAS systems going offline, and folks are going to struggle to troubleshoot them until either a patch is released that allows us to tag the quality of service of our data, or we stop doing that from a design perspective. So, what is the most common type of troubleshooting for BAS IT? Oh, my goodness, there's so many. It depends on if you're talking about compute or data or application or network. So, I mean, it's really, it just depends on the domain. But when I think about troubleshooting and I think about BAS, if I think where most people spend their time, it's usually on the network. It's trying to figure out routing issues, trying to figure out BBMDs and BDTs. That's where most BAS folks have trouble. I don't see a lot of database or applications or compute issues. That being said, with us going to pushing a lot of the compute processes down to field controllers these days, I'm expecting we will start seeing more issues like that popping up in the future. All right. Okay, well, I'll give you all a couple more minutes for whatever questions you want to ask, and if I don't get any more, we'll just call it a day. Tell your friends to join our webinars. There you go. That's the call to action. Did I get a new mouse? Yes, I did get a new. Oh my gosh, that was so annoying when it was double clicking on everything. I've got this fancy pantsy expensive high DPI mouse, and after a couple years it'll start to go. And so yeah, I finally went and bought a new one. Will we be able to download the recorded webinar? Yes, you will get an email with the, well, will you be able to download it? I don't know. I'm not sure. Maybe, possibly. Let me know when you get the email. I know you'll get an email with the webinar. I don't know if you'll be able to download the video or not. I know we're going to put it on YouTube. We put all of our webinars on YouTube, so. When it comes to IP, most people think of speed. Do you think IP infrastructure will overtake MSTP network? Yeah, so that's something I addressed earlier in the webinar. I think it will. I think it will take, probably 5 to 10 years for it to happen. The thing is that when you can do IP, when they fix the power issue with controllers failing, and when, well, I don't put, one more thing. I don't put our paid courses on YouTube. So if you want the paid courses, those are on our LMS, but our free courses and our free webinars are on YouTube. Okay, so back to your question around IP. So IP, right? I think it will. So if I was a betting person, if I was an executive and I was planning out market share and product strategy and all that jazz, I would look at past. It amazes me how folks don't look at past industries. It's so easy to see the parallels in our industry to the industrial industry, where you're largely seeing the adoption of IP now because the price of the solutions has gone down. See, what happens behind the scenes at a manufacturer is manufacturers go and they have cost to develop product. Once that cost is sunk and realized, then you need to make up the cost. You do that by pricing the product at a premium typically. and you get your early adopters. They purchase the product, and then after that, early adopters purchase the product. The price starts to go down as you start to get more orders. You're able to negotiate better hardware rates and costs from the suppliers who are supplying your parts. And as the technology naturally evolves, the cost of the transmission medium and the technology itself is going to be lower. So that's what's going to happen to IP. It's going to get to a point, I don't know if it'll ever be at parity with MSTP, because simply of the fact that you're not going to be putting all these advanced application features in an MSTP controller. So you'll always have a compute cost that's a little bit higher, but I think it'll get close enough to parity or equality between prices that it just will make sense to utilize IP. Did I get the network table headers correct? Device, IP, MAC, port. Yeah. Ultimately, Michael, it can be anything. Whatever works for you. That's my recommendation. But I mean, whatever works for you, whatever works with the IT group you're working at. That's another cool thing. So I like to do little tricks like that when I'm working with IT folks. Is I like to think of the things I can give them control of, so that way they feel in control, and that naturally gets my requests satisfied. So if I can tell them, hey, what would you like the network layer to look like? Do you have any templates that you'd like me to follow? Do you have a network device list that you would like me to follow? Because there's something about seeing something you created as a network engineer, that you're not going to be as likely to deny something you came up with. So it's kind of like how whenever you're coming up with an idea, you let people contribute to the idea, because no one wants to call their baby ugly. And so by letting them contribute to the network design, that they are getting emotionally invested in it. Now I know we're going like all new age here, but it's a strategy that works quite well for working with IT folks. Excuse me. Our IT wants star for everything. The folks with the money are pissed. Well, I would just understand why they want that. Because the thing is, here's the thing, right? Let's go back to this. They will say they want star for everything. I'm putting myself in their shoes, and they are probably saying it's cybersecurity. We don't want devices hanging off of devices, so we need star for everything. But yet they have a switch with a wireless LAN controller, right? And then they have APs all over the place coming off of the switch, right? And guess what those APs do? Those APs have a bunch of hosts that connect to them. What is that logically very similar to? It's just like our bus. It's exactly like our bus, because you have multiple MAC addresses and multiple IP addresses coming through a single point called an access point. Logically, it is exactly the same. And that is what I explain to IT folks when they start to get all worked up over this little architecture right here. Okay, so all right. Hopefully there are engineers on call. They really need to educate themselves on the expertise they should have. I hope so too. That's probably the next area we're going to take our courses. I've been debating whether, because we've pretty much built out every course that a technician, programmer, designer, project engineer, project manager on the controls contractor side could possibly need. I mean, we've got everything from sales to project management to programming, everything. So at this point, I'm figuring out our business strategy, whether we're going to do owner courses next or we're going to do design and consulting engineer courses next. I'm trying to figure out which market I want to step into next. Because I think we can help both. And obviously, owner operators there's a lot more of them, but it's going to be a lower cost course. So I just got to decide. So we've got a couple of folks here who are saying they're consulting engineers here and they're absorbing this. And yeah, I mean, I know it's a lot to take in. I feel for the consulting engineers these days starting to pull technology into their specs because it's changing on a daily basis. For new infrastructure, is it recommended to isolate BAS IT network from other networks? Not necessarily. It all depends on your IT security policies and your risk exposure. So our podcast episode this week was on cybersecurity and risk exposure and all sorts of stuff at buildingautomationmonthly.com/182. So that I would listen to that. It'll give you some good perspective on risk exposure. I'd be happy to provide you my opinion on how the engineer training could be provided. Yeah, feel free to reach out to us. Just shoot us an email. I'd love to hear from you. All right. Anything else, folks? I mean, I've got the whole afternoon just blocked out, so it's all good with me. This is going to make an awesome video once I put it on YouTube. I feel like this is going to be extremely valuable. If people actually sit through all hour and a half of it, I think it'll be pretty good for them. I know our webinars tend to run over. I should just start. I feel like I should block them out for an hour and a half, but I feel like the whole culture and society has been so conditioned to webinars being an hour that if I did that, no one would attend. So, when designing an IT network for BAS, do you really need to use subnetting? Yes, you have to use subnetting. There's no way you can design any network without subnetting. You simply can't, just because of public IP versus private IP and private IP, how it utilizes or how it works. If we assigned everything as a static from all the public IPs, we would have no IPs in the world. The only reason we have IP addresses is because of subnetting. It has to be done. There's no way around it. Oh, we got one more. Okay, which is better for BAS, IT, virtual, or physical servers? Um, it just depends. So, virtual servers, they have the benefits of virtual. Actually, I mean, if you have the technical capabilities to implement and support virtual servers, I pick virtual servers 100% of the time, just because they have failover. I mean, their cost is minimally more. Failover, you can do imaging for fallback. And just you have elasticity for scaling of resources. With a physical server, you have none of that. What is the primary criteria to decide if using static or dynamic IP? If you can support dynamic IPs, use dynamic IPs. If you need them to act like static IP addresses, then just do a dynamic IP with a permanent lease. So that way, if the IP address or device fails, it will go and automatically grab that IP address again. That's what I have set up at my house. It's all DHCP, but I have preferred leases. Like if I go CMD. It's not going to show it like that, is it? There we go. See, it says preferred right there. So I have DHCP. You can see, right? My lease obtained, lease expires, but it's going to expire, and it's automatically going to refresh right back. When integrating field devices, such as fire alarms, chillers, etc., what are the most important parameters of the BACnet IP? Well, One, that they support BACnet IP. I mean, I don't mean that to sound sarcastic. I hope it doesn't. It's just there's a lot of stuff that says it's BACnet IP, but then when you actually get into it, it doesn't really support it. So that's number one. Number two is making sure that you understand your device instances and device object IDs. So making sure you understand that stuff, and making sure they're not duplicated. Your BBMDs and BDTs are important, and your I think that's pretty much it. That's what I would focus on. It's not like lawn where you have to have the CPs and snivets and NVs and all that jazz, and your snivet types have to match, and if they mismatch, you're gonna have issues. BACnet's much more forgiving on data type mismatches. What is the difference between object IDs and device instance numbers? So object IDs and device instance numbers, object IDs are going to be the actual ID of a object. Okay, so an object could be an AI, a object could be a BI, an object could be a calendar. There's what, like 60 plus BACnet object types. A device is a type of an object, and the device instance number is a property of the device object type. Okay, so a object ID is going to be its ID, whereas the device instance number is going to be a property of the device object. Does that make sense? It's almost like I created a course on BAS protocols. You're welcome. Seems like every time I say the word thrice, another question pops up. So going once, going twice, going thrice? No? All right. Well, so this will be on YouTube, and you all can go in the comment section below the YouTube video. Feel free to ask questions there, and I'll answer them. And then other than that, thanks a ton. I hope you all have a good rest of your day. And this will probably be uploaded today, if not tomorrow. So, all right, folks, have a good one. Take care.